Hey students, today I'll be talking about potential energy. What is energy? If something can do work, we say it has energy. Energy is just the ability to do work. To do some kind of work, we always need energy. Suppose I get up in the morning and I have to run. Okay, I'll run for a period of time. Then I will need some food because I need to have energy to do work. Now, there is a type of energy called mechanical energy. Okay, there is another type of energy called sound energy. There is a type of energy called light energy. There is a type of energy called electrical energy. There is a type of energy called nuclear energy. There is a type of energy called hydraulic energy. There is a type of energy called potential energy. Okay, so potential energy comes from the class of mechanical energy. The mechanical energy is divided into two classes. First is potential energy and the second is kinetic energy. Today we will be talking only about potential energy. So what is potential energy? The energy which a body has due to its position. Yes, due to its position, its location is called potential energy. Suppose there is a mass m at some height h above Earth's surface. Does it have some kind of energy? Can it do work? Yes, it can. If I just left this mass, it will fall down. And when it will fall down, it will force the dust particles below it, the air particles below it to move downwards. So the air particles will be moving downwards. So those particles will be experiencing force and will be having displacement. That means force into displacement, work. That means a body which is at any height above Earth's surface has some kind of energy due to its position. And the energy due to position is potential energy. So here it has gravitational potential energy. Gravitational related to gravity. So an object at height h above Earth's surface has a gravitational potential energy mgh. This is an approximation, but it is true for high school standard. So higher is the height of object above Earth's surface, more energy it has. Let me tell you some different way to understand this thing. Suppose there is a mass at the surface of Earth. I lift that mass and take it to a height h. I have to do work. Why? Because that mass will be attracted towards Earth. I have to apply force on that mass and then take it to a height h. So I have done some work. I have spent some energy. Where does this energy goes? It goes into potential energy of that mass. Whatever work I have done has been stored in the form of energy. Why? Because energy can neither be created nor be destroyed, can only be changed from one form to another. So whatever work I have done to pull this mass above Earth's surface has now been stored inside the mass like gravitational potential energy, which has a formula mgh. Okay. Now coming to the second case. Suppose we have a spring which is initially of this length and I have compressed this spring like this. Okay, I have pushed this like this. While pushing it, I have to do some work. I have to force it downwards. Where does this energy went? This energy went into potential energy of spring or elastic. Okay, spring is an elastic material. Does a compressed spring has energy? Yes, it does. Suppose I put a ball on this compressed spring over here. I put a ball and leave it. What will happen? The spring will force this ball upwards. So the ball will start moving. That means there is some kind of work done on the ball by the spring. And hence, spring must have energy. So a spring which is kept normally has no energy. But whenever we compress it, we put energy inside it by compressing it. And that energy is called elastic potential energy. What is elastic potential energy? It is half K delta X square. Delta X is the compression, how much I have compressed it. And what is K? K is some kind of spring constant. Okay? It depends upon the type of spring. Some springs are compressed easily, some are compressed with more difficulty. Okay? So K depends upon spring. If I expand this spring, if I try to stretch this spring, then also I have to do work. Then also I have put energy. Then also the spring must be having elastic potential energy. So a compressed spring and a stretched spring both have elastic potential energy. I give you another example. Suppose I have a bow. Okay, what is a bow? This is a bow, okay, through which we shoot an arrow. Now the string, yes, this string is elastic in nature. If I pull the string like this and hold it like this, now to pull it I have to put some kind of energy, and this energy has now been stored as elastic potential energy. So a stretched bow has elastic potential energy. Do you agree? Let me elaborate it more. When I stretch this bow like this and I leave it, it will force the arrow to go forward. So it does some kind of work on the arrow. So from where this work comes from? Of course, from the elastic potential energy. So a stretched bow also have potential energy. Okay, so we have two kinds of potential energy, gravitational and then elastic. Now the third case, a complex one. Suppose I have a charge Q1 here and a charge Q2 here. I have two charges, okay, and they are kept at R separation. Suppose this is a positive charge and this is also a positive charge. Does this charge, due to its position, have any kind of energy? Yes, it does. If I leave this charge, these two charges will repel. Positive and positive repels. Like charges repel. So this charge will start moving. And when it will start moving, it will again force the air molecules to move and will do work. And this work comes from electrostatic potential energy. That is stored between two charges. Yes, it is important. Between two charges, not a single charge. Okay, you say, sir, it is not positive, it is negative. Then also it has energy. If I leave this system, positive and negative will attract, and ultimately both the charges will move. And when they will move, they will again do work. And this work comes from electrostatic potential energy. So by far we are confirmed that any particle has a certain kind of energy due to its position or its location, or the better word will be configuration. And this energy which is due to configuration is called potential energy. Okay, Is that clear? Now we will discuss this gravitational potential energy in a bit depth. Okay. So let us talk about gravitational potential energy. It is an assumption that a body at the surface of Earth has zero gravitational potential energy. This is just an assumption. Okay, we have made it that at the surface of Earth a body has zero potential energy. Now whenever I lift this body of mass m to a height h, it gains some kind of gravitational potential energy. How much? M, acceleration due to gravity g, into h. The symbol for potential energy will be U. So we say U is equals to mgh. Okay. Now, suppose I took a mass from height h1 to another height h2. What will happen to its gravitational potential energy? Will it increase? Will it decrease? Or will it remain same? Here it has U is equals to mgh1 potential energy, and here U is equals to mgh2. Let us call this U1 and this U2. So definitely U2 is greater because this height is more. So whenever we take an object from height h1 to height h2, we experience a gain in potential energy. How much gain? Final minus initial, mg h2 minus mg h1. So mg will be common and we get h2 minus h1. This is the change in potential energy, delta U, change. So this is change in potential energy. I hope this much is clear to you. Thank you.